So let's say here's the ground, and here's the X is going to be where the airplane wants to drop this stuff. So the problem with waiting until the airplane gets right above X and then dropping the package, the problem is that the airplane is still moving. It has to still be moving. Airplanes can't really stop in midair. They'll probably fall down and crash. Airplanes have to keep moving. So if they wait till they're right above X before they drop the package, unfortunately, it's not going to do this. Okay, that's not what will happen realistically. What happens is that since the airplane has a little bit of forward momentum, well, a lot of forward momentum, when they drop the package will also have that forward momentum. So the package will actually drift. It will take that forward momentum. They're going to miss the target by quite a ways, actually. So that's not the correct strategy. The correct strategy is actually for the airplane to drop it early. So the airplane's going this way. The airplane's got to drop it early so that the forward momentum of the package as it falls will hopefully hit the ground where it's supposed to hit. Okay, so the question is how many seconds? So from here to here, it's a certain distance. We can find out the distance, but we also want to know how many seconds before the airplane actually gets there that they have to drop the packages. So that's the gist of the question. So I'm going to redraw the proper diagram. It's a bit smaller though, so I have space to write the solution. So we'll have the ground, and let's say X marks the spot. This is where they want the package to hit, and the plane is going to have to drop it somewhere earlier. And the forward momentum will have hopefully the package hitting the spot. It'll fall in a parabola. It'll be a projectile. Now the initial velocity of this airplane, and therefore the package, because the package is on the airplane, that initial velocity, which I'll label as Vx, is 180 kilometers an hour forward. And the height of the airplane above the ground is 160 meters. Okay, that's the information we're given. So it looks like I don't have too much information here. Well, let's list things out. I'll list them out into two columns: vertical information and horizontal information. Okay, vertically, the velocity is initially 0. Okay, it starts with a purely horizontal velocity, so this can be 0 meters per second. The acceleration vertically is going to be due to gravity, 9.8 meters per second squared, down. The height that it has to fall is 160 meters, so that means the displacement of the package is 160 meters down. That's the displacement of the package. Oh, actually, I do have a lot of vertical information, so I think I am good. I can find the time. And I'll use the uniform acceleration formula number 3. Okay, so the v1 delta t term all ends up being 0 because the initial y velocity is 0. Let's solve for the time. Done this a number of times in this set of projectile problems. The negative will be inadmissible for time. Okay, I'll go to my calculator. And round it to 2 sig figs, I'm getting 5.7 seconds. Okay, so I think that's it actually. To give us the horizontal velocity, we don't end up needing it for this question. Maybe there is a follow-up question. Maybe question 28 is a follow-up question to this, where you have to find some x stuff, but this is the answer to the question that's asked here for number 27.